So even though full relational database engines like SQL Server and Postgres and MySQL are all viable options for big cloud-enabled applications, there are a lot more scenarios where something smaller and more lightweight makes sense. Cases like small websites, portfolio projects if you're a student or a learner just getting started, embedded applications. All of these situations are overkill for a full relational database engine, and that's where SQLite comes in. SQLite is a small, self-contained database. It exists in a file, and you don't have to install a full database engine to use it. Now today I'm going to show you how to download and install the tools and get your environment set up so that you can start working with SQLite. So let's get started. Now to get started, the first thing we're going to do is open our terminal or command prompt. And this is just to check if SQLite is already installed or has been installed before. There are some versions of Mac OS, for example, where SQLite comes bundled with the operating system and it will already be there. So opening the command prompt, just type SQLite 3. And if it says it's not a recognized internal or external command or gives you some other kind of error, that means it has not been installed and it has not been added to our path. So where do we go get it from? Well, the SQLite has a downloads page. So if you go to sqlite.org/download.html, you will see the download page here. And all you need to do is find the pre-compiled binaries for your specific operating system and processor. Now down here, I'm on Windows. I am going to install the tools for Windows. Now this includes not only the DLL that lets you run SQLite, it also includes some command line tools and some other goodies. So let's go ahead and download that. It's going to be a zip file. When we open it up, we're going to want to extract it. So where should we extract it to? I recommend you just create a folder in the root of your hard drive named SQLite and extract it there. So when I hit extract all, I'm going to change this to C:\\SQLite and say OK. And it now has extracted it. And for the next step, we're going to add it to the Windows path so that it will work in our command prompt. So now we've closed out our download window in the extract tool, and we're ready to add this to the path. Now, the path in any operating system is where it searches for commands. So when we were in the command line prompt and we searched for SQLite and it said it wasn't found, we need to add it to the path because that download and extract does not do that automatically. Now in Windows, we can search for environment variables. Edit the system environment variables. And if you're in Windows 10 or an earlier version of Windows, you can find it in the System Properties Advanced tab. And here's the button for environment variables. And when we open this, we see that there are user variables where there's a path, and there are system variables where there is also a path. And the difference here is that the user ones will only be enabled for me when I'm logged in, while the system ones would be available for any user that is logged into this computer. I'm going to add it to the system variables because other people in my household use this computer and I would like them to have access to SQLite. Now that we're in the edit, we'll say new, and all it wants you to do is put the path where that command is located, which we extracted to C:\SQLite. And when I say OK, 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 and now we open our command prompt, and if we type SQLite 3, we will see that now we're on version 3.48, and the prompt changed to read SQLite, which means now we can add commands and work with SQLite using the command prompt. But first, let's exit this prompt because we did not specify a database file. SQLite databases are all self-contained in a SQL file. And when we didn't specify a file name, it connected us to an in-memory database. We would like to work with an actual file that is saved in between sessions. So I'm going to go ahead and say .exit because I'm going to show you how to do this from scratch. We could open one using the open command here, but let's show you how to do it from the beginning. So we'll back out to the C drive and let's create a directory called databases. Then we'll go into that directory. And then we're going to type SQLite 3 and then the name of our database. Now let's create a database of products. So we'll say products.db. Now we are inside the database using the command prompt. And we can see here that the command prompt did change from the directory to SQLite. And that's one of the ways we know that we're in this interface. Now, being a command line tool, it displays things by default in a certain way. There are some modifications we can make to make the data read better, make it behave nicer. So I'm going to add a couple of these right now. First, whenever I write a query, I would like the headers to be shown for the query. Those are the column names, because that's helpful for me. So I'm going to say .headers on. And then I would also like the output format of my queries to be in columns, because that's just easier to read. So let's go ahead and say mode column. And then for fun, let's also keep track of how long our queries take to run. So we'll say .timer on. And now we're ready to create our first table. Let's create a table for products and a table for categories. So for the most part in SQLite, because it is ANSI SQL compliant, the SQL that you write will be very similar to what you see in other database engines. So let's just go ahead and say create table, category, and then we're going to add some fields. And if I hit enter, it will indent. So we're in the middle of a command right now, and it's going to let me continue typing. So I'm going to say category ID is going to be an integer value, and it's also going to be the primary key. And this is not case sensitive. I type things in a case sensitive way because that's my habit from being a database administrator in a prior life. And then we're also going to have a column. Oh, I forgot my comma, but that's okay. SQL is not white space sensitive. So we'll say category name, and this will be a text field, and we're not going to allow nulls. And then we're going to close our parenthesis, and we're going to put this option called strict, because I would like the typing to be strict. By default in SQLite, it is not strict type. It will attempt to convert things similar to how JavaScript does. Being a database person and understanding how data can get corrupted, I choose strict mode whenever possible. So I'm going to go ahead and hit enter, and now that query ran. And we should have that table in the database. We're going to check that in just a moment. Next, let's create our product table. So I'm going to say create table, product. And again, we're going to start adding the columns one at a time. So I'm going to say product ID. And I'm going to show you that the casing doesn't matter. Integer, primary key. And then we're going to say category ID. This will also be an integer, not null. That's going to be our foreign key. We're going to have our product name, which is going to be text. It is also not going to be null. We're going to have our launch date of the product. Now I'm going to store this as an integer because we are going to use the Unix time, which is stored in integer values, for this column, because I'd like to demonstrate how to handle that. And then the last thing we're going to do is we're going to wire up our foreign key. So we're going to say foreign key, category ID, references, and then we're going to point it at the right table, which is our category, and what column is the key that it should bind to. That is the category ID. And then the last thing we're going to do is we're going to close our parenthesis, and we're also going to make this strict. And now we should have two tables. Now, my screen was getting a little busy, so I wanted to clear it. In the Windows command shell, you would type CLS, which stands for clear screen. Now in SQLite, that's not a valid command, but if you type something and it's not sure what you're doing, it's going to put you in the command area where we would type SQL. A lot of people get stuck here when they're first beginning. All you need to know is that commands can be terminated with a semicolon. So if I do that, it will then error out. Now you can call out to the shell and use shell commands. So when I wanted to clear the screen, all I need to do is type .shell and then the command I would like the shell to execute, which is clear screen. And there we go. Now we have a nice clean place to continue our demo. Now first, let's make sure that our tables have actually been added. And you can do that with .tables. And they call these dot commands. There's a whole bunch of them. But here we can see the category table and the product table. And if we'd like to see more information about them, like what columns and things are inside them, we can use the .schema command. So if I type .schema and then product, you'll see that it will give us the create statement that was used to create that table. And there's all our columns, all our settings, the foreign key reference. So you can use this to explore your database using the command prompt. When we declare an integer primary key, it is going to set that up to be allowed to automatically increment, which means as we insert rows into our tables, it will automatically assign the next available key value if we don't provide one. And this is a little different than some other databases, because in some databases, if you set something up to be automatic, you aren't allowed to pass a value to it. SQLite does allow this. So it's either going to be the value you give it, or it will be the maximum value plus 1 in the case of these integer columns. Now let's go ahead and insert some data. And I'm going to copy paste so I don't have to type all this product information and things like that. But as you can see here, we're going to paste this anyway. This is just a standard insert statement. We're going to insert into category, we're going to pass the name, and here are the values. This is indistinguishable from SQL Server and some other databases because it's ANSI SQL. And I'm going to hit enter. That was committed to the database. And then let's also add some product information. So I'll go ahead and do that, paste anyway. And here are a list of products that are going to be associated with those categories. And I know that category 1 is going to be electronics, category 2 is going to be home goods, and category 3 is going to be office supplies because of auto numbers. It's going to start at 1 for this previous statement. And the one thing I want you to look at here is this string ftime method that we're using for the launch date. What this does is it converts a human readable date like January 1st, 2024 to Unix time, which is going to be in integer format. So I'm going to go ahead and hit enter. And now this data has been inserted into the table. So now we can do a select query. And because we set up these foreign keys and everything, we can do joins. So let's get a list of all of the products and convert the Unix time back to human readable format. So let's go ahead and clear the shell. And let's paste in our select command. And to start with, I'm just going to print out the launch date as is so that you can see how Unix time is stored. And we can see here that the launch date is a whole bunch of numbers because this is the number of ticks past the date in 1970. And this is what Unix time is based on. Now, if we'd like to convert that back, we can use a function called datetime. So let's look at the difference here. So here, when I paste it in, you can see we used the function datetime. We're passing in the launch date column, and we're telling it that it is in Unix epoch format, and this is going to convert it back to something that is human readable. And you can see here now the launch date shows in a human readable format. Now, why would we want to use Unix dates versus just storing a date as text? Well, the advantage of storing it as text is obviously that users are able to read it without you having to do any conversions or mess around with the database query. But the problem is if you want to compare dates or sort them or do math on them, then you will want to have this in a numeric format. Otherwise, you're going to have to do conversions to do the math and then convert it back, which is slightly less efficient. And let me just point out that this is often a false choice. If you're using a small database and you don't have a lot of data and storage isn't really a concern, you can always store two versions of a date. You can store one version in the integer format so you can do math on it really quickly, and then you can have another column that has that date represented as text so that you can quickly display it and print it for users without having to do any conversions. So either or both. Now, as part of this demo, I did use a bunch of the dot commands like .shell and .schema and .tables. Where do you find these commands? Well, you can find them on the website. They're all in the documentation. You can also say .help. And if you put .help, it will actually list out all of the dot commands that you have available to you in this interface. And there's a lot of useful stuff in here. Some of the stuff might be a little beyond you if you're a beginner, but don't worry about that. But if you are looking for something, you can find it usually in the .help. Now, I'm done with this, so I'm going to say .exit. That's going to take me out of the database, and it's going to commit things. Now, if we do a dir, you can see here is the products DB that was created by our SQLite command. And I'm not really a huge fan of command line tools. They're great if I have to run some small scripts or something really quick. But when I'm really trying to examine data and work with data, I actually prefer graphical interfaces for that. I know there are some snooty developers out there who think that command lines are the be-all end-all. I like to be able to click things and open multiple tabs and keep data open. So next, let's go get a tool that will let us do that. And that tool is called the SQLite Browser. So let's open a browser to SQLiteBrowser.org, click on the download link, and here are all the downloads of this tool. And there are other tools out there, let me be clear about this. This just happens to be one of my favorites. Now, it does have installation for Windows and Mac OS, even with Homebrew and Linux. So again, come in here, click the installer to download the one for your operating system. If you're on a modern Windows machine, the standard installer for 64-bit Windows should be fine. So let's go ahead and click that. It's going to download it pretty quickly for me. And then we launch it. Go through the setup wizard. Obviously, I agree to the terms. Do I want icons on things? And, where do I want it to be? I don't like anything on my desktop. I like my desktop to be clean. So I'm going to say next. It's going to ask you if you want these extensions. Those are all fine. Where do we want to put it? C:\program files, DB Browser for SQLite. That's fine. We'll go ahead and install it. It'll just take a moment to install, and we'll be ready to use it and open our database. So let's go ahead and close our browser. Let's search for SQLite, DB Browser. There it is. We launch the app. And here in this application interface, this is a pretty simple interface. It only has a few buttons. Now, projects are used if you want to store a bunch of SQL scripts and settings. You can save those to a project. You can reopen them later. We're just going to get started pretty quick and dirty. So let's go ahead and say open the database. We're going to go to our databases folder. We're going to choose the products DB and say open it. And now we have all of these tabs. So in the database structure, we can see we have our two tables. We can graphically drop those open. We can see all the different settings, the types of the columns. We can see whether they're nullable or not. So this gives us a great way to browse everything that's in our SQLite database. And then in the browse data, we can select a table and we can see the data that's actually in the table. And we can see it in its raw format there. And again, if we want to run queries, we can do that. So let's go ahead and grab our previous query that converted the launch date from the Unix time to a human readable format. There's a tab here called Execute SQL. And in here, we can have multiple tabs open at the same time. And I can just paste my query in here. I can tell it to run it. And there we go. We got the query that we got from the command line, and it does give us some additional information. And it says it was finished without errors. There's our timing and all that stuff. We can click on individual cells, and we can make edits without writing SQL if we want to as well. I'm kind of a stickler as a former DBA. I like to write SQL queries for everything. But, if you're more of an Excel type person, this is a quick way you can edit things and do things like that. Now let's go ahead and update one of our records. Let's say update product set product name equals, and let's change this to an AI smart speaker because Lord knows we need AI in everything these days. So update product, set the product name equal to AI smart speaker, where the product ID, and I'm pretty sure that's ID 1. Yeah, it is. So there we go. And we'll go ahead and run this query. It did update it. Now, the one thing I want to point out about this tool is that it's very friendly about snapshots and rolling data back. This data has been changed, but it has not been committed. I can undo my last command, or I can revert changes, which will go back to the last save point. And it basically starts a save point whenever you start making changes. So I could do multiple updates here on the same save point. If I hit revert changes, it would revert all of them back. Undo will only do the most recent one. But if I want to commit the change, I just hit this write changes button and that saves it. And this isn't how SQL works in the command line tool, and it's not how it works in other tools. You have to actually explicitly set up transactions and rollback points. This tool does it automatically, which is something I actually kind of dig about it. So once that's done, then if we go back to browse the data, we see the AI smart speaker has been updated and the saves have been committed. And again, like I said, beginners, they'll come in here and start using this tool. They'll forget to hit the write changes button and they'll close out of it. And then they'll go back in later and they're like, hey, where are my changes? Well, you forgot to commit them. So just be aware of that. This tool is excellent. It's pretty easy to find your way around it. So if you have any trouble, there are help documentation and things like that. But for somebody who is strong in SQL and familiar with other tools, this is pretty easy to pick up.